we are going to start this class with a problem, that is with the power calculation. So we have previously dealt with all the concepts with the voltage, current and everything. So we are going to continue our discussion on those things. So this is one problem, guys. So here we have already see how to calculate the power, like conventional sign to calculate the power, that thing we have discussed. So we are going to apply that thing and we are going to solve this one. So the question is that calculate the power supplied and power absorbed by each element. So we have to find the power supplied or absorbed by each element in the figure and show the power absorbed which is equal to power supplied. Means the energy of conservation which is working here or not, that we have to find out. So thing is that P1, P2, P3, P4. So four types of power that we are going to find here. So let me take the first one, that is a P1. So we can calculate the P1 directly. So we know that power calculation is directly current into voltage. So here if you see in this loop the current flowing which will be 5 amps. Okay, so in this entire loop the current will flow in the 5 amps. So no, not like that, up to this one. So this up to this one. So let me remove it because this may control. So if you see in these elements, so if we laser it, so this element here the current flow up to this one, the current flow will be 5 amps. So here we know already the plus or minus the voltage over the power one, if you 20 volt into 10. So if you multiply both the thing, we can clearly see the power which is equal to 100. So here we are clearly saying that it is a positive 100 because the leaving sign of the power is the, here if you see the current is leaving over the positive side. So here we can say the power is delivered. Okay, power is delivered. Something. So in this case, the current is entering into the positive terminal. So in this case, we have to take the negative analogy that power is absorbed. Okay. So P2. Even we can take that as a minus 60. In some cases, we can take that as a power absorbed. So thing is that here 12 volts into 5. So which is equal to 60 volts. For now, I am taking everything in a positive. But here the thing is that I am going to mention this as a absorbed. So because the current is entering over the positive terminal. So next to P3. So in P3, it is a power is again entering over the positive terminal. So this is also 8 into 6. So which is equal to 48, right? So 48 watt power is absorbed. Okay. So here if you see, there is a dependent element. So dependent element, what the dependent element is this is a current dependent current source. Current dependent current source. Okay, CDCS. So these things are already dependent, already informed in the previous lecture. So please watch that one. So if we can calculate the P4, what will be the voltage across this is this voltage is from here to here, it is 8. So parallel voltage are same, so it will be also equal to 8. So these are some in a 12th standard, 10th standard itself we see, right? So voltage will be same in the parallel and the current will be same in the series. So if you see these two, P1 and P2 has the same, this is in series, so the current flow is same. Here the P3 and P4 in parallel, so voltage across them is same. So 8 into what will be the current flowing here is that here they are given the int that is high. So I is equal to 5. So if we multiply the 0.2 into 5, then this will be equal to 1. So even they have given this one directly. So this is 1 ohm. So if we multiply this one, so this will be 8 watt. So here if you see, if we take the thing, the current is leaving over the positive terminal. Means here the power is delivered. Okay. So power is delivered. So here now we have to calculate the power supplied as well as power delivered. So if we calculate the power supplied means that is a delivered case. So which will be 100 plus 8. So which is equal to 108. So power absorbed. So let me take the reverse case. What is the power absorbed is that 60 plus 48, that is also 108. So here we have proven that this circuit follows the laws of conservation. The power absorbed and power supply is same. So we have proven the question. I hope you guys are able to understand the things, right? So this is very easy. In a even examination point of view, they may trick that question, but the power calculation and those things will be quite straightforward. You guys can clearly solve it. So let's now start the next up thing, that is the types of circuit elements. Circuit elements. So you guys can state many circuit elements, right? So if we ask plenty of guys what are the circuit elements that is present in a network, everybody will say RLC, resistor, inductance and capacitance components, right? So that is the same thing. So we are going to clearly discuss about resistance, inductance and capacitance clearly each lecture. So I will take a plenty of time to make you guys master in all the topic, because you guys may know, yeah, plenty of teachers will think that easy guys will be familiar in this, so we can skip this topic. That should not be. You guys need to learn it very perfectly, guys. So what you mean by resistor, what you mean by resistance, those things, even these small difference many engineers may not know. So we have to cover these very things. The very fundamentals is very important. I am clearly stating that fundamentals will help you everywhere, guys. So resistor, a device that opposes the flow of charge or flow of current through it is called resistor. The amount of opposition of it is measured by the property of resistor, that is called resistance. So let me clearly write it. A device, a device that opposes the flow, device that opposes the flow of charge or flow of current, which will be called as a resistor. Okay, flow of charge. Okay, so this we call as a resistor. What do you mean by resistance is that there is some measurement quantity. So how we can quantitatively measure this one. Okay, so the amount of opposition. So here thing is that the amount of opposition offered is measured by the property of resistance. Measured by property of resistor, that is called as resistance. Okay, I hope you this difference is familiar for you guys. So let us take few examples over the resistance. So we know the SI unit, which is equal to ohm. Okay, so this is a very common known question. This is ohm. So the resistance, which can be related to the resistivity over length divided by area. So this is what the formula that we guys can take over it. So the material with resistivity rho. So this is what the thing. So for an example, if you are having a cross cylinder, a cross section area where we take the area and the length, so where we can calculate the resistance, how much resistance that will apply with the help of the parameter, some constant parameter that is called resistivity. So resistivity is the property of the material by which it offers resistance, but resistivity does not depend on size of the resistance. So this is very important, guys. So here the rho, which is nothing but a resistivity, so this is some constant. So let me write it here, resistivity. So resistivity is the property of the material. Resistivity is the property of material by which it offers resistance. But this is what this thing is will be very fine for you. So let us extend this understanding over the Ohm's law. I think we haven't studied this Ohm's law in this network course. So let me also brush up the thing. So Ohm's law is a very fundamental rule, guys. So we already applied Ohm's law even in the power calculation we have used it. But let's now see theoretically. Even from 10th standard we are studying this, right? So whenever a potential difference is applied across the conductor, a current start to flow, which is proportional to the potential difference across the ends of the conductor under the constant temperature. So let me, if you guys, what I am said, plenty of guys may know because Ohm's law is a constant definition. Plenty of guys may gossip, but if you guy is new to this topic, then how we can clearly explain is that a single line can explain this one. So this one. So here if you see the amount of current flowing in the conductor will be directly proportional on the voltage potential difference across the ends. So if we remove the resistance, the proportionality constant can be removed with the help of 1 by R. Okay, so this is what Ohm's law. So wherever guys, so don't mug up the formula. So even I can understand in examination we need to write the laws and facts exactly the same words, but we are now studying in engineering concepts, right? So where we no need to mug up or remember any kind of things. So even these kind of small definitions can be understood or can be known with the physical significance over the equations. So I will suggest you guys to make over these things. So here if you see the cause is potential difference. So because of potential difference only current is flow. So the cause effect. So this is independent parameter, this is dependent parameter. Okay. So where resistance R is the constant. So this we know with this formula V is equal to IR. So this is a well-known formula for our memory basic purpose. Okay. So let me also again say the definition. Whenever a potential difference is applied across the conductance is applied across the ends of the conductance, a current start to flow, which is proportional to the potential difference across the end of the conductor under constant temperature. So here the important thing is that constant temperature, guys. So this is not with the variable temperature. So at a particular temperature, we are going to study the things. So let us see another one thing. Why material possesses resistance? So generally, even a normal material will consume some power. Means it will produce some heat energy that is caused as a resistance. So why every material producing some resistance? So if there is any reason behind it, so let's discuss that thing. So why material possesses resistance? Okay. So you guys can also comment comment the answers in the comment section. Okay. Let's take an example. At any temperature T, both electron and the thermal energy means 3 by 2 kT. Okay, some thing will be there. So like both electrons and thermal energy will be there. So due to the thermal energy, electrons have random motion while the kernel vibrates about their position. Okay, so due to the random motion of electron, they keep colliding with each other. So as well as with the kernel, that hinders their motion. Thereby, resistance is offered. So at the thing, what they are saying is that due to thermal energy, thermal effect or thermal energy. So because of this thermal energy, what's happening is that electrons have random motion. Electrons have random motion. Random motion. While kernel vibrates about its position. Don't think these all are not needed. So even in interviews, they may ask these kind of questions because fundamentals, right? So anybody can ask you any question. We need to ready about everything. So that's why I'm teaching each and every points what I am studying in the books. Okay. So due to this random motion of electron, what will happen is that electrons collide. So electrons will electron colliding with each other. As a result of it, the resistance will be produced. So as a result, resistance will be produced. At a T is equal to 0 Kelvin, absolute temperature, no thermal energy, no random motion, no collision. So R will be equal to 0. So if R is equal to 0, then that we call as a superconductance. So that is not naturally possible, right? So that is what. So conductors, in a conductor, if you take a conductor, if we increase the temperature, if a temperature is increased, then what will happen? The randomness will increase. So the randomness will increase. So because of these randomness increases, what will happen? The collision will increase. Collisions. So because of these collisions, what happened? Resistance will increase. So that is what the general flow. So thing is that if you take the temperature coefficient of the things, the conductor have positive temperature coefficient. So when the temperature is increasing, the resistance will increases. Okay. So to reminder, the conductors have positive temperature coefficient, while semiconductor and material like magnets have negative temperature coefficient. Okay. So here this is how the thing that we have to take into picture. So please try to remember these things. So these will be very much effective for you guys to understand the things. So why resistance produces heat? So this is another one thing. So as we said, when current flows through a conductor, electrons flow and gain come kinetic energy. So when the electron collides with the kernel, they transfer the kinetic energy to other electrons present over it. So because of that, there will be the kinetic energy and transition of the energy over the band will be transferred that as a heat. Okay, that is a phonon. So because of these resistance cause, there will be energy loss. So resistance converts the electrical energy to heat energy. But if the heat energy is utilized by any other things, then that energy can be transferred from one form to another form. So that is what the thing that we have to say here. So next class, let's discuss some short circuit and open circuit concepts. So that will be very much helpful while we are going over this network theory subject. So I hope you guys able to understand what you mean by resistance. So in next class we discuss short circuit, open circuit, and then we will starting with the inductance, and then separate lecture for the capacitance. I hope this will be very much good for you guys to build your concepts on understanding the network theory, because only these three elements are dependent on our entire subject. So that's why I'm suggesting you guys need a strong understanding for all these concepts. Okay, stay tuned guys, like, share, subscribe channel.